Good day, grade 10s and 11s, and welcome back to the anti-science theory. And today we're going to be looking at um, what we call redox reactions. So we're going to be looking at redox reactions. And for grade 11s, this should be a topic that is quite familiar. If you happen to have forgotten a few things, you most definitely can't have forgotten the definitions. But anyway, even if you did, that's really not going to change too much because we're going to get into all of that in this video. So before I go any further, what do we mean when we speak about redox reactions? It's a very important question. What is it that we talk about when we talk about redox reactions? Well, in simple terms, when you talk about redox reactions, we're basically talking about reactions that deal with the transfer of electrons. So these are reactions, right, that deal with basically a transfer of electrons. Well, if you want like a more precise definition, you would say these are reactions in which there is actually a transfer of electrons between certain elements, right? So we're talking about a transfer of electrons. So that's what we talk about when we talk about redox reactions. So these are reactions that deal with a transfer of what exactly? Of electrons, right? Remember electrons, what do we know electrons? We know that electrons, every electron, even the superscript tells you that an electron is negatively charged. This is something that we should know. An electron is negatively charged, a proton is positively charged, a neutron is just neither. But those are things that we should have known, I think, from grade 8, if I'm not mistaken, but nonetheless. So look at redox reactions, and those are particularly reactions that deal with the transfer of electrons, knowing that electrons are negatively charged particles, right? Cool. Now, the word redox reaction, well, don't really have a more a term, rather a proper English term that I can use. I don't want to say it's a compound word because now I just think probably talking about something else. But the word redox is formed from basically two different words, right? So two different words were used to form the word redox. Now those words are, for starters, oxidation. So the OX is oxidation, and the RED is reduction. Pretty sure it's actually starting to ring a bell for the grade 11s. Reduction and oxidation. So redox, like I said, I don't know if it's proper for me to say it's a compound word, but hey, what the heck? It is a compound word where the first three letters red basically entail that you're talking about reduction, and the OX is oxidation. Now, these are two different terms with obviously their respective definitions. Now, in a typical exam paper, you would be required to define these words in two different ways. So there are two different ways in which you would be required rather to define reduction, to define oxidation. So what exactly is reduction? By definition, so we have the first way. You may be asked to define oxidation and reduction in terms of electron transfer. So when they want you to define it in terms of electron transfer, well, then you'd be looking at something like this. So when you define oxidation, for starters, so you define oxidation in terms of electron transfer. You say that oxidation is a bit too thick for my liking. Okay, it's cool. We say that oxidation is the loss of electrons. Oxidation is the loss of electrons, right? So losing electrons, the loss of electrons. By the way, this E minus, we should know, just basically means electrons. I've just would be quite a tedious activity to just write the entire word. But please, if you actually want to do that, please do that. I actually advise that you do that. Right. So oxidation in terms of electron transfer. So you get a question paper, and you get a question under redox reaction. The first question says to you, define oxidation in terms of electron transfer. Right now, journey with me. You define oxidation in terms of electron transfer. Do not think about anything else. Just write down the answer. Oxidation is the loss of electrons, and that is it. You actually you attain your 2 marks just by writing that. Then they actually ask you again, define reduction. Not actually again, or they could ask you to define reduction in terms of electron transfer. What is reduction? Now remember, it would only make sense that if someone loses something, whatever it is that you lose must be received or gained by someone else. Right, so think about when you did acids and bases, you defined an acid as a proton donor, and what happens to that donated proton? It's accepted by a base according to the Lowry-Bronsted theory. When you have an acid, according to the Lowry-Bronsted acid definition, we say it's a proton donor. Now, what about the base? The base is a proton acceptor. So there's one that donates so that the other one can receive. So in this particular case, the same thing happens. So oxidation is the loss of electrons. Those electrons that have been lost are then gained by whatever it is that undergoes reduction. So reduction by definition is the gain of electrons, right? So one loses the electrons, the other one gains those lost electrons. I hope you're all on the same page on this one. Okay, it's as simple as that. So define oxidation in terms of electron transfer, it is the loss of electrons. Define reduction in terms of electron transfer, it is the gain of electrons, right? Cool. Then you may be asked again to define these two words in the second way. So the second way is when you define it in terms of oxidation numbers. In terms of oxidation numbers. Terms of oxidation numbers. Okay, now we're going to get into a bit more detail on what oxidation numbers are and what they actually do, probably in the next video, just so I can try to avoid having a very lengthy video, you know. Okay, so what is oxidation? What is oxidation in terms of oxidation numbers? Now think about it. If we're defining oxidation, and we're talking about oxidation numbers, doesn't that actually sound like, oh my gosh, these two are basically working together? So this one is you could basically say oxidation numbers, oxidation. So there must be a direct relationship between the two. Well, if you think that, then you're very correct, because if you define oxidation in terms of oxidation numbers, we say that oxidation is an increase in oxidation numbers. It is an increase in oxidation numbers. So I just wanna get all the definitions out of the way, and then we're gonna get to the nitty-gritties and the cracks of this entire topic. So oxidation is an increase in the oxidation number, and reduction, what do you think reduction is? Ha, you guessed it. And reduction then will be the decrease of oxidation numbers. A decrease in oxidation numbers. So we talk about a decrease in oxidation numbers, we talk about reduction. So in this particular case, you may be asked in the exam to define these two words, and please bear in mind, the examiner will forever be specific. They will never just leave you and just say define oxidation and that's it. Well, if they do that, never really seen a question like that, but if they do that, I honestly don't know. If they actually just say define oxidation and your teachers actually reckon that there is no errata or something, then just define oxidation either as the loss of electrons or an increase in oxidation number. But they are, in fact, not usually, but always specific. So they will be specific and they'll say to you, 6.1, for example, define the term oxidation in terms of electron transfer. How do you define it? You say it's the loss of electrons. That's it. Define the term reduction in terms of electron transfer. How do you define it? It is the gain of electrons. Loss is oxygen, gain is reduction, right? Or there's also a very common mnemonic that some people use that is known as oil rig. Never really was a fan of mnemonic, but probably could work for the next person, you know. So what this mnemonic basically entails is that the O stands for oxidation, right? Oxidation. And then the I is basically is, and then the L is loss. So oxidation is loss of what in particular? the main character, electrons. Now the red part basically says reduction. Reduction is gain of what? Main character, electrons. So, I mean, it could work for someone, could not. If you actually know how to remember these definitions without using the mnemonic, that's fine. If you want to use the mnemonic, that's perfect. No one's going to judge you as long as you get it right. Cool. There's also another mnemonic that I actually learned a few, like, I actually didn't know this back when I was in high school. I really didn't know about this one. But that's mnemonic, I know there's a GR, right? There's a GR part. And then I forgot the other one. But I know one of them is GR, and then the other, if I'm not mistaken, it should be Leo. Really hope I'm not wrong about this. I really forgot these two things. Okay, so this one basically is a mnemonic that works for the second definition. So you could say that, what it basically means is that G is it GR? Okay, just trying to remember. Oh yes, so GR is basically to gain, yes, to gain electrons, basically means you're reducing. So gaining electrons is reduction. That's what they basically mean. So gaining electrons is reduction. And then this one will then be losing electrons. Aha, you guessed it, is oxidation. Losing electrons is oxidation. So losing electrons is oxidation. So these are just a few mnemonics that you could use or not. Really does not matter as long as you have it right. That's all that matters. Right, a very important point. When we speak about something that when we say that something undergoes oxidation, so when something undergoes oxidation, so we have a certain substance and it undergoes oxidation, we say that substance oxidizes, right? So, you know, when you go back to English, either home language or first additional language, oxidation is the noun, oxidizes is the verb. So when it undergoes the process of oxidation, we say that particular substance oxidizes. So when they ask you in the exam, why would you actually say magnesium, for example? Why do we say magnesium oxidizes? Well, you tell them it undergoes oxidation. That is, it loses electrons or it increases in the oxidation numbers. However, you actually, depending on the given question at that particular moment in time. And then you have the second one, which is reduction. Okay, so you'd have reduction. Substance that undergoes reduction is known to reduce. So what is what do we call, say, I'm given fluorine, and fluorine somehow undergoes reduction either by gaining electrons or by decreasing in oxidation numbers. So whatever it is, once you identify fluorine as the one that undergoes reduction, we say that fluorine reduces. Okay, these are some very important points that you must not forget. Right, so anything that undergoes oxidation oxidizes, anything that undergoes reduction reduces. Another very important point, very important. You guys must know, please make sure that you do not forget what I'm about to say right now. It is very important. Okay, so for starters, might get a bit confusing, so just please make sure that you pay perfect attention. Right, so for starters, when you talk about a substance that undergoes oxidation, or the substance that oxidizes, so if you say a substance oxidizes, we basically say that substance is the reducing agent. Similarly, when you say that a substance reduces, we say that substance is the oxidizing agent. It is the oxidizing agent. So when it undergoes oxidation, It is known as a reducing agent. It's a bit too thick for my liking. Yeah, so we say that it is the reducing agent when it undergoes oxidation, and we say that it is the oxidizing agent when it undergoes reduction. So notice how these words work. These words are very they are opposites of each other. So when something oxidizes, it is the reducing agent. When something reduces, it is the oxidizing agent. Now, why exactly do we say that? It's not important for you to know this, but you must actually understand what they mean. Well, okay. So when we say a substance, I'm just gonna abbreviate, and I hope you guys can actually catch what I'm doing. When you say a substance oxidizes, we say that it is the reducing agent. Now, why is that? I need you guys to be very, very, very careful in this one. So, if you say that a substance oxidizes, it is the reducing agent. Now, just a typical example. If you look at a certain reaction, say we have a reaction, just make a use of a different color. Say we have a reaction between magnesium plus oxygen, and this gives us magnesium oxide, right? Okay, that's going to be a 2, and then that obviously gives rise to a 2 over there. Okay, now it's balanced. Okay, so now we have magnesium and oxygen to give us magnesium oxide. Now, how does it work? How do we actually say something is oxidizing? Now, we speak about what we call oxidation numbers. So, in this particular case, you'd be looking at the oxidation number of magnesium, oxygen, magnesium, and oxygen. So what I basically mean is that magnesium on its own, so magnesium being in this particular case, and magnesium being in magnesium oxide, right? So that's what we look at, and that's what we focus on. We also look at oxygen on its own, right? And we also look at oxygen when it's in magnesium oxide. So what am I basically saying? So what I'm saying is, when we say a substance oxidizes, remember the second definition in terms of oxidation numbers, what do you think it is? When a substance oxidizes, it increases in oxidation numbers. Yes. So in this particular case, I'm just going to move this down to bring it here. Okay. So in this particular case, when we say that it oxidizes, we mean that it increases in oxidation numbers. Now, you should know, we're going to get into that probably in the next video. You must make sure that you know that any pure substance or any pure element has an oxidation number of 0. Very, very important. Any pure element or pure substance has an oxidation number of 0, right? So in this particular case, a pure element in this particular case would be magnesium, right? This guy over here is a pure element. Similarly, this guy over here is a pure element. Why? Because it's magnesium and just magnesium. It's just like you take magnesium off the periodic table and you just put him right there, and you take oxygen off the periodic table, it being a diatomic element, you just put it right there. But your compound that you form is obviously magnesium oxide. But now, so what does that basically tell me? So that basically tells me that okay, so this is how it's going to work. Since magnesium is just magnesium on its own, right? So just maybe explain a bit further what I mean when I say pure substances have an oxidation number of 0. So say I have an example like fluorine. Just fluorine has an oxidation number of 0. Zinc, just zinc has an oxidation number of 0. Another element, titanium, just titanium has an oxidation number of 0. You know, aluminium, just aluminium has an oxidation. So it's basically saying if you just find a pure element that is an element that you would just look at and just see that, okay, this was taken directly from the periodic table, nothing was done to it, you give it an oxidation number of 0. So what that basically means is that with this example, these two numbers will basically have oxidation numbers of 0. So this one will have an oxidation number of 0. He will also have an oxidation number of 0, right? Because these are pure elements. However, remember, in magnesium oxide, you must remember that back in grade 10, you had to deal with something like, when you had to form certain compound, you would then say, okay, me knowing that magnesium is in group 2, and oxygen is in group 6, and has a charge of 2 minus, because these two are the same. Well, sorry, these two are equals in one. The charge on magnesium is 2 and the charge on oxygen is 2. Well, they have different signs. What they basically do is they cancel each other out, and you then result in magnesium oxide. So what basically happens is that in magnesium oxide, the oxidation number of magnesium is 2. Because of what? Because of that 2 plus charge over there. So that 2 plus charge gives us the oxidation number. We're going to get into more detail on oxidation numbers very, very soon. Okay. And then with oxygen, since it's O2 minus, the oxidation number of oxygen in magnesium oxide is 2. Now, why is it that it's not 0? This is not 0 because it's not just oxygen alone, but it's oxygen with magnesium. It's not just magnesium alone, but it's magnesium with oxygen. Hence, we don't give it an oxidation number of 0. But in the reactant side, we had magnesium and just magnesium. Thus, magnesium had a 0 oxidation number. And oxygen was just oxygen, thus the oxidation number was 0. But in magnesium oxide, it's magnesium and oxygen, thus the oxidation number cannot be 0 in that particular case. So please pay very, very careful attention to that. Yeah. Now, so if we look at these and we say, okay, so what then happens? So notice something. For the oxygen, the oxidation number of oxygen is supposed to be 2 minus. I'm so sorry. It had to be a negative 2. Remember this. It's O2 minus, so it had to be a negative 2. My bad. Okay. So what do you then notice? You then notice that the oxidation number of magnesium went from 0 to a 2. Now, what do you think happened? Did it increase or did it decrease? Aha, yes. So the oxidation number of magnesium increased, right? And we look at oxygen, we notice it moved from a 0 to a negative 2. Did it increase or decrease? Yes, it basically decreased. Hope you guys are seeing this. Now, what does it tell you? According to our definitions, we said that if something has an increase in oxidation numbers, we say it undergoes oxidation. If it has a decrease in oxidation numbers, it undergoes reduction. So in this particular case, I hope you all can see that our magnesium, right? So magnesium undergoes oxidation and oxygen undergoes reduction. Hope you guys can see that. Why? Because the oxidation number of magnesium increased and the oxidation number of oxygen decreased. So in this particular case, do you guys agree with me? I hope you do agree with me when you say, when I say that basically means that magnesium is the reducing agent and oxygen is the oxidizing agent. Right? Because magnesium undergoes oxidation, thus it is the reducing agent. Oxygen undergoes reduction, and thus is the the oxidizing agent. Now, why exactly is that? Remember, I wanted to explain that part. Now, think about it. Like I said initially, when something oxidizes, that is, when something gains electrons, I'm so sorry. When something loses electrons, it oxidizes. When it gains electrons, it reduces. So when magnesium undergoes, remember, so we said we've already identified magnesium as the one that undergoes oxidation, and we say that oxygen undergoes, reduction. So oxygen undergoes reduction. So what then happens? What do we say about this? So if magnesium undergoes oxidation and oxygen undergoes reduction, what does that tell us? that basically says, now the reason you would say it's a reducing agent is because if you think about electrons, right? So we're not going to talk about oxidation numbers now, we're going to think about electrons. If you've identified magnesium as the one that oxidizes, hope you agree with me when I say it's the one that loses electrons. It oxidizes, that means it loses electrons, right? So it basically lost its electrons. It lost the electrons. This one gained those electrons. This one gained the electrons, right? Now, we say that something that oxidizes is known as a reducing agent because whatever oxidizes, now journey with me. Whatever oxidizes causes something else to reduce. I'll repeat that. Whatever oxidizes causes something else to reduce. So in this particular case, we had magnesium. Magnesium oxidized and forced oxygen to reduce. That is why we say the one that oxidizes is known as the reducing agent, because whatever it is that oxidizes forces something else to reduce. What is oxidation? Loss of electrons. What is reduction? Gain of electrons. So when I lose electrons, I oxidize. When I lose electrons, I oxidize. I force someone else to gain those electrons. So when you say something is oxidized, the reducing agent part, so the first word before the word agent tells you what it makes the other substance do in simple terms. So if I oxidize, I'm the reducing agent. The word reducing, just before agent, the word reducing tells me what I make the other substance do. So if I oxidize, I make the other substance reduce. Thus, I am the reducing agent. If I reduce, I make the other I'll get to that part. So when I oxidize, I force the other substance to reduce. That is why they call me the reducing agent. One last time. When I oxidize, I force something else to reduce. That is why they call me the reducing agent. Because when I oxidize, I force something else to reduce. Thus, I am the reducing agent. That is, when I lose electrons, I force someone else to accept or to gain those electrons. When I lose electrons, oxidize, I force someone else to gain, reduce those electrons, right? So in this particular case, whatever oxidizes is known as a reducing agent. What exactly happens when something is reducing? So when something reduces, so you have something that reduces, we say that it is the oxidizing agent. So in this particular case, whatever reduces because something oxidized. Journey with me. When my friend accepts electrons, he only accepts those electrons because I gave them away. So reducing agent is because I oxidized. Oxidizing agent is because I'm reducing. So when I'm the oxidizing agent, when I oxidize, I force my friend to reduce. When my friend reduces, he's reducing because I oxidized. Thus, whatever reduces is known as the oxidizing agent because it reduced because something else oxidized. It gains electrons because something else lost those electrons. It gains electrons, reduction, because something else lost those electrons, oxidation. Hope we're very clear on that one. Could be quite confusing. Really hope it's not. But if it is, then do drop a comment down below and I will get to you as soon as possible. But it should be quite comprehensible. I really tried to explain it to the best of my abilities, but you don't need to know this. You are never asked to give a reason why we say something is oxidizing. Well, you are, but to give a typical answer to that question, maybe they would say, give a reason why we say magnesium is oxidizing. You don't say because it's a reducing agent. No, you just tell them that it oxidizes because it lost electrons or because it increased in oxidation numbers. That's how you actually would answer those type of questions. Cool. So with the use of that example, I really hope you actually understood why we actually say something that oxidizes is the reducing agent. Remember, when you oxidize, you lose electrons. You force someone else to gain those electrons. What is to gain electrons? Reduction. Thus, when I oxidize, I force you to reduce. So just think about it. It's just you and your friend. So think about you and your friend, right? So you have in your hand a burger. Your friend doesn't have anything. So you decide to say, I'm full. I don't want this burger anymore. You give it away. Your friend who is so hungry is forced to take that burger. So what did you do? So think of the burger as the electron. Think of yourself as just a certain substance or element, right? So you, right, are the one substance, right? And you have with you a burger. That burger is the electron. You have your friend who is another substance and he does not have any electrons. He does not have a burger in that case. So you decide to say, I don't want to eat this burger anymore. What do? You then give it to your friend. So the burger is the electron. You give the electron to your friend and you force him to accept that burger. You force him to accept that electron. What do you call something that accepts electrons or gains electrons? Something we say that it is reducing. So when you oxidize, you give away the burger, you force your friend to reduce, accept the burger. When your friend has accepted the burger, he reduced, right? So now we're looking at this case. So now we're looking at this part here. When your friend reduced, it is because you oxidized. So he accepted because you gave away. I hope you're getting that. I give away, I force you to accept. You accept because I gave away. Hope it is very, very clear. Okay, so now we've looked at what oxidation is, two definitions, what reduction is, two definitions, and yes, so that exactly covers everything on this lesson. I just thought of doing oxidation numbers right now, but I thought this video might be a bit too lengthy, so there's going to be a story for the next video. So from me to you, I hope that was clear. I hope you guys understand why we say something is a reducing agent and something is an oxidizing agent. I hope that everything that we've done thus far has not been problematic to any one of you. And if it has, please do ask your question in the comments and I will get back to you as soon as possible. But from me to you, shall see you in the next video. Thank you very much. Goodbye.